Okay, this is Chapter 1 review for standard geometry. Number 1, how many planes can be drawn through any 3 non-collinear points? And this is based off of a point, line, and plane postulate, which states that through any 3 non-collinear points there exists exactly 1 plane. The best way to think of this, if you think about the surface of your desk, and let's say that we drew 3 points, 3 non-collinear points on the desk. The only plane that would travel through those 3 points is where the desktop is at. If I tried to make another plane that went through those 3 points, it's not possible. So we could have a plane going down this way, but it would only go through maybe 1 or 2 of the points. It wouldn't go through all 3. So my answer here is exactly 1. Number 2, true or false, D is collinear with A and B. So collinear means on the same line. So D is on the same line with A. D is also on the same line with B, but A and B are collinear with each other, but D is not collinear with A and B. They're not all 3 on the same line. So that would be false. So number 3, name the intersection of plane P, this plane right here, and the plane that contains points A, C, and D. So A, C, and D, basically the plane that travels through this face of the object. And the place where 2 planes intersect will be a line. So the line of intersection, the common points of intersection, would be on line AC. Number 4, find the length of RS. So we're measuring in inches. Our increments are 16ths. If I count from here, starting at 0, 1, 2, and so on over, I will notice that there are 16 marks. So we're past 1, so we have 1 inch, and then we just count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer is 1 and 11/16 inches. On number 5, find the distance between -4/6 and 8-1. For this problem, we'll have to use the distance formula, which is down here. So we need to define our coordinates. So we can call one of our points x1, y1. I could also call this one x2, y2. It doesn't matter which one you name what. So I'll call this one x2, y2, since I call this one x1, y1. Then I just substitute my values in to the formula. So I would have 8 minus -4 squared plus -1 minus 6. Squared. So we simplify from here. 8 minus negative, or plus 4, is 12. -1 minus 6 gives us -7. So simplify a bit further. 12 squared is 144. And -7 squared would be 49. Notice that both of these values are positive. If you square a positive or square a negative, you'll always get a positive. So we combine those terms and we get the square root of 193. So since this is not a perfect square, we can leave our answer like this as a radical, square root of 193, or we can round it using a calculator and get 13.9. Number 6, find the length of PQ. So to find the length of PQ, which would be this portion, we want to take the whole and subtract this part away. So 29.2 minus 10.8 gives us 18.4 centimeters. On number 7, find the value of y if b is between a and c, so make a diagram for that. AB is 3y, so label. BC is 5y, label that. And AC is 56, so label that. So to find the value of y, we need to set up some sort of equation, and we're going to use the segment addition postulate, which states that the sum of the two parts will equal this, the whole. So we want to take 3y plus the other part, 5y, and set it equal to the whole, 56. If I combine my like terms, I get 8y, and if I divide both sides by 8, I get y is equal to 7. Always go back to the problem, make sure that we are giving what we're asked for. So it says find the value of y. Sometimes it might say find the length of the AB, so we would have to substitute back in. But in this case, our answer is just y equals 7. Number 8, find the distance between 310 and 77. So once again, we use the distance formula. This time I'll call this one x2, y2, just to show that it doesn't matter. And this one x1, y1. So we substitute in our coordinates. 3 minus 7 squared plus 10 minus 7 squared. So 3 minus 7, that would give us negative 4. 10 minus 7, that would give us 3. So we move on to the next step. Negative 4 squared is positive 16. 3 squared is 9. That adds up to 25. Now, in this case, since 25 is a perfect square, we wouldn't leave our answer as the square root of 25. We would actually take the square root of it and get 5 as our final answer. Number 9, find the coordinates of the midpoint of segment LB if L is 11.8 and B is negative 4.3, and we have the midpoint formula here. So once again, label one of your points x1, y1, it doesn't matter which one you choose, and the other x2, y2. Substitute your values in. So we're going to add up our x's, so 11 plus negative 4 divided by 2, and add up our y's. So 8 plus 3 over 2. So simplify this. 11 and negative 4 gives us 7. 8 and 3 gives us 11. And if we want to write that as a decimal, divide by 2. So we get 3.5 and 5.5 for the midpoint. On number 10, use the number line to find the midpoint of DF. So basically just the middle. So 1, 2 points away, 1, 2 away there. So E is smack dab in the middle of D and F. So our midpoint is E. Number 11, what type of angle is AEF? So AEF, we can see, is past the 90-degree mark. So since it's past that, since it's greater than 90, it's obtuse. Number 12, find the measure of GED if ED bisects GEF and GEF is 150 degrees. So here's GEF, which we know is 150 degrees. We also know that ED bisects the angle. which means that it splits it in half into two congruent angles. So if they're congruent, we just take 150, we divide by 2, therefore our answer is 75 degrees. On number 13, find the measure of angle FBD if FBD and DBE are complementary, which means they add up to 90, and FBD is twice the measure of DBE. So since we don't know either of the angles, we have to define a variable. So we'll call the measure of DBE x. If FBD is twice the measure of DBE, then it will be equal to 2x. Since the angles are complementary, then that means if I add them together, so if I take x and 2x, I should get 90. So we solve this equation, combine like terms, we get 3x is equal to 90. We divide by 3, x is equal to 30, and then we substitute back in. So the measure of FBD is equal to 2x, or 2 times 30. So my answer is 60 degrees. Number 14, which pair of angles are supplementary? Supplementary angles add up to 180 degrees. So when we see a diagram like this, we don't see any measures on there, so we can't actually add, like, let's say it gave an angle of 20 and an angle of 160, we can clearly say which angles are supplementary. But in this case, we look for straight lines and linear pairs. So if we take a look at this line, which is 180 degrees, I notice that I have angle ABC and CBD. So if I add this measure and this measure together, since it's a straight line, I should get 180 degrees. Angles ABC and CBD are what we call a linear pair. For number 15, which angle is vertical to angle ABC? So vertical angles, by definition, are angles formed by intersecting lines which are non-adjacent. So they're not next to each other. So if I look at angle ABC and I extend these sides in the other direction, that will give me my vertical angle. So ABC and EBD, or DBE, whichever way you want to call it, are vertical angles. Number 16, if the measure of angle CBF is 6x plus 18, find the value of x so that CB is perpendicular to BF. So if CB and BF are perpendicular, then that means that they form a right angle, which is equal to 90 degrees. And we're given an expression for CBF, so we're going to substitute in 90 and set that equal to 6x plus 18 and solve this equation. So we subtract 18, we get 72. If 6x is equal to 72, we divide by 6, and x is equal to 12. Take it back to the original problem, and it says find the value of x. So we don't need to substitute it back in, we can stop right there. X is equal to 12. Number 17, find x if ABC is 4x plus 9 and EBD is equal to 25. So earlier on number 15, we said that ABC and EBD are vertical angles. So once again, ABC is this angle, EBD is this angle. Vertical angles are always congruent. That's something that is always true. So if they're always congruent, then they have the same measure, which means that we can set them equal to each other and solve for x. So 4x plus 9 equals 25. Therefore, 4x subtract 9 is equal to 16, and x is equal to 4. Take that back to the problem. It says find x. So we don't need to substitute back in. We can stop right there. X is equal to 4. Refer to the figure, name two acute vertical angles. So, keyword here, acute, less than 90. Vertical angles. Whenever you have intersecting lines, the vertical angles are the non-adjacent ones. These two are vertical angles, as well as these two are vertical angles. Now, we can clearly see that these two are obtuse, greater than 90, so that's not my answer. We can go back to what I said first. These two angles, we can see that those are less than a right angle. Those are less than 90. So my answer would be angles QRU and SRT. In 19, angles SRQ and QRT form a linear pair at the vertex point R. Which 3 points, Q, R, S, or T, are collinear? So which points lie on the same line? And it says right here, don't use the above diagram. So even though we have the same names up here, we don't use this diagram. We need to make a diagram. So SRQ and QRT form a linear pair. So remember the definition for linear pair. A linear pair is a pair of adjacent angles whose non-shared sides forms a straight line or opposite rays. So we have a straight line, and then we have two angles, this angle and this angle right here, forming our linear pair. So it says, which 3 points are collinear? Well, Q is up here by itself, so S, R, and T lie on the same line. Number 20, given A is between Y and Z, so let's make a diagram. YA is 22, label it. AZ is 3x, label it. And YZ is 52, label that. Find AZ. So on this problem, we're going to have to substitute back in. So we have to figure out what x is first. So by the segment addition postulate, our two parts added together is equal to the whole. So we have YA, which is 22, plus AZ, which is 3x, is equal to YZ, which is 52. So no like terms to combine, so we can go straight to subtracting 22 from both sides, and we get 3x is equal to 30. Divide by 3, and x is equal to 10. Now let's take that back and substitute in for AZ. AZ is 3x. So AZ is 3 times 10, or 30. For the bonus, find the measure of A if A is complementary to B. So we can write that down, the measure of angle A plus the measure of angle B is 90. They add up to 90. They're complementary. And B is supplementary to C. So the measure of angle B plus the measure of angle C equals 180. They're supplementary. They add up to 180 degrees. And we have what we can substitute in. So B is 15x minus 2, and C is 25x plus 22. So we have to substitute into the second equation because we don't have an expression for A just yet. So B is 15x minus 2, I substitute in for my B, plus for my C, I substitute in 25x plus 22. And then that's equal to 180. So combine your like terms. And subtract 20. And divide by 40. So x is equal to 4. We're not done yet. We need to find the measure of A, so we need this equation. So if we know what B is, we can figure out what A is. So let's substitute 4 back in to find out what B is. So 15x, 15 times 4 minus 2, and that would be 58. Now substitute that in to figure out what A is. So the measure of A plus the measure of B, which is 58, is equal to 90. Subtract 58 from both sides, and the measure of angle A is 32 degrees. And that's it. Hopefully you found this helpful. Good luck on your test.